Hi, I wanted to demo and show what my AI can do. So I worked on an AI that works specifically on scenes, and scenes throughout different rooms is specifically what I'm looking at. To test it out, I did want to create the difference between a kitchen and then the bathroom. So it can identify the basic concept of a kitchen, and let the user know this is a kitchen or that is a bathroom. Unfortunately, with the timing, I decided to update my Linux computer. And unfortunately, that ruined a lot of the environmental variables. So I had to rewrite a lot of the pathways and update a lot of the system. But I'll get into a demo of what the checkpoints look like and what it looks like when it's training for the data. So first thing that we're going to do is I use this in a virtual environment. And from what I've heard, it is very hard to train AIs in non-virtual environments. It's definitely possible, but virtual environments, ironically enough, that actually prevents you from some of the stuff that just happened to me, where a lot of the updates um, should have uh, had nothing to do with the old virtual environment. The problem is that TensorFlow uses CUDNN or CUDN, I guess. And this does need to get updated. Because of that, it was a little bit confused about where to grab that information from. But virtual environments, you can have an older version in a virtual environment, and your computer won't freak out about that. It won't say, well, wait, I'm working with this variable, so why are you using an outdated version or something like that? Virtual environments are really good for AI testing because you can keep it the same. And I used Conda. That seems to be the easiest for me. I found out how to use this pretty quickly. So, in my opinion, I would definitely use this. There's a lot of tutorials online that I'll share in my GitHub page about where to go for that. But first, what we're going to do is do Conda activate, and then I made something called TensorFlow. So Conda activate TensorFlow. This is activating the TensorFlow environment that I created. So now that we're in the TensorFlow environment, what I'm going to do is I'm going to run the code, which happens to be train model.py. Obviously, I need to be in the correct folder. So cd desktop list, AI prototype. Whoops. And then we're going to list here. It should be here. Perfect. Okay. So what I'm going to do is this is my main, the main thing that we're going to look at right here. Train model. So I split all of these up into different Python files. And there's actually a reason why. And when I go into the code, I'll show a little bit of why I did that. But train model is the one that we're going to run. So we just do Python 3 train model.py. And I'm also going to go over a little bit of what it's saying over here. So these are, this is the estimated time. ETA obviously means exactly what you think it means. So let's take a step back and it's running a little bit slow right now. Let's see if okay, so I can see it right here. I'm not sure if the screen is frozen in Zoom, but epoch, oh, it looks like the session crashed. Okay. Sorry, let me try that again. I think my computer's running a lot, so it probably just broke off the connection. But anyway, so you'll see epoch 5 out of 10. So this epoch is a checkpoint. I created checkpoints in my code because this is going to be running for a while. Think about like days. I might run this for days, which is why in order to show you like working model, it would have needed to be running for a few days now. So that's why I'm only showing you these checkpoints. But if I'm running this for days, you can imagine I would not want to lose all of that work that the computer literally just sat there putting in work all day and all night. So of course I set this up in checkpoints, and they're called epochs in this. So it loads up an epoch, and the last epoch it worked on is 2. It kind of showed that. Let's see. I don't know why this stopped this file format. Okay. And it looks like there is an unconsidered error that I didn't know was going to happen. Well, not error, but a problem in my code, which is I don't want it to stop at just 10 epochs. I want it to run for longer. So I'll look into the code and try to find that out later, but let's go over the code first and I'll show you. Yep, I can find exactly where that is. Set epochs right here. So, but anyway, let's go over the first, the main program that's running this whole thing. So I define the model right here, just as I say in my code. I make it sequential. Now this is a lot of mathematics that it's running over in the GPU. The GPU is the best for trying to calculate these types of models. But what it's doing is it's pulling a few different equations and it's making these equations into something called neurons that eventually the computer can run as spin up as either true or false, or a few different, or like a number from 1 to 9. And these neurons connect with other neurons that have that exact same situation. So it can almost look at a few different pixels, like almost a few different pixels at the same time, and try to offer up like a value that that pixel has. So what it does is this is going to create that neuron field that I was talking about. And then the compilation is going to be set with this right here, the atom, and then it loads the data, or it reads the data from train images, which I have 2 folders labeled kitchen and bathroom. And then the model checkpoint is actually written in a different place. So both of these are different parts of the code. So load model is a class that I made in the load model file. So if we could take a look at that really quick, what it does is it loads exactly from train images. And then the data directory, so this is a little bit redundant, but what I did is I tried to make sure that that it read from train images. The best model.h5, that's where it's saving these checkpoints to. I believe, if I remember right, let's take a look at the file and see what it did. But I believe like in the cluster file, it's going to save it as a zip file. That way it doesn't take up a lot of space, because some of the times these can take up a lot of space. So let's take a look. Model checkpoints. Oh, it doesn't have anything yet, so that's another thing I should look at. Oh, right here. So it's a .h5 file. For me, it looks like it's not, well, it's not going to open because it's only readable with an AI. So of course the computer's going to say, why are you opening that file, kind of thing. But what you're going to want to do is it reads those, as I said, in epochs. And I'm going to change that later. So it's not just finishing at the 10th epoch. I don't know why it says 5, but it ends at 10. But I'm gonna have to do a little bit more research about why they chose the .h5 file. I did read this from another GitHub file, obviously not copied completely, but the .h5 file was something that saved it. So that's what I decided to use. I used another AI that was called a clustering AI. It uses texture as a way to identify images. And although I really liked that idea, their system for saving the updates were a lot more complicated than this. So this saves me a lot of time to check out each and individual point of the checkpoint. Because what I really wanted to do is work with this and make sure that it could read the max pooling 2D function, the con 2D, and the equation that I used for this. But that is basically my AI. If you wanted to see something that it will most likely turn out to be, if not a little bit worse, obviously, but it's kind of an old project, but Places 365 is what it's supposed to look like. And you can actually check that on the web. So I definitely recommend checking that out. You can put in your own room or your own different thing. And like what I'm trying to do right now, it'll identify that and say like, oh, that's the Grand Canyon, or that's that was a national park or something like that. So, but thank you for watching, and let me know if you have any questions.